This is CPM Calculus Chapter 4, number 102. Without graphing, so let's not use our calculator to graph it, analytically determine where the function y is equal to x cubed plus minus 7x squared plus 15x minus 2 is increasing. Okay, then check your answer with a graph. So go ahead and do it after. Got it? So this means we want to do it algebraically, right? So what do we know about a graph is increasing, right? Well, remember that when we were studying graphs, increasing means if y is increasing, then we know this means is the same thing as the derivative y prime is greater than 0, right? This is the key thing to take away, because we can go ahead and determine where y prime is greater than 0, right? So let's go ahead and do that. Let's first look at y prime, right? Y prime is just the derivative here, so that's 3x squared minus 14x plus 15. And where is this greater than 0? Okay, so we just want to know, we want to solve this inequality, right? We want to solve for x, right? And once we solve this inequality, we know where y is increasing. All right, so how do we solve inequalities? Well, remember, what we could do is when we have a quadratic greater than something, we can go ahead and say it's equal to 0 first, and that's going to show us the points where y prime is equal to 0, right? If y prime is equal to 0 at certain points, let's just say, just look at this for an example. If it's equal to 0, right, we know in between those zeros it's either above 0 or below 0, right? And to the left, we either know it's above 0 or below 0. Again, above or below. It will never be above and then below, because if it did that, we would have another 0, right? So we're going to solve this for all the zeros, right? And we know since it's a quadratic, it's just going to have 2 of them. And then we're going to determine, algebraically, we're going to test a point on all these sides to determine is it positive or negative, right? Because once we do that, we're going to be able to say exactly where y prime is greater than 0, which means y is increasing in that region. Okay? So let's go ahead and do that. Let's go ahead and start setting this equal to 0 first. Right? Y prime we're looking at. So it's equal to 0. We can go ahead and use the quadratic formula, right, to solve what x equals. Or, yeah, let's do that. Because we could also just factor this using the box method. But let's practice using the quadratic formula. X is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. And that's equal to negative of negative 14. So 14 plus or minus square root of b squared is negative 14 squared minus 4. A is 3. C is 15. Let me write that a little neater. All over 2 times A is 3. Okay? So then this is going to give us, let's go ahead and bring out our calculators, right? I'm going to enlarge this calculator a little bit if I could. Yep. Okay, so we have 2 answers. One's going to be plus and one's going to be minus, right? So 14 plus square root of negative 14 squared minus 4 times 3 times 15. Okay, and I'm going to put this all over 2. So I'm going to need to put the whole thing over 2a. I'm going to put the whole thing in parentheses in the numerator. Otherwise, I'm just going to be dividing the right part of the expression. Divided by 2 times 3. I'm putting the 2 times 3 in parentheses as well. So when I do that, I can check here, and it's equal to negative 3 or positive 3, right? So it's equal to 3. Now, if I go ahead and change this to 14 minus, right, because I want to do both. So I'm going to delete the plus and put minus. I'm going to get 5 over 3, 5/3, right? And I know that 5/3 is just 1.666 continuous, right? So 5/3, I can even say 1.67 or whatever I would like. Right? I could put 1.66 continuous 2, right? So that tells me y, right, is increasing. Well, we know y prime is equal to 0 at this point here, which is going to be 1.66, and this point here, which is 3. Okay? So now that I have those 2 points, I can go ahead and check all of the regions around, right? I can check right here, and here, and here. Because once I check one point to the left, I'm going to know whether it's going to be positive above that, everywhere to the left, or below. Okay? So what points am I going to check? I'm going to check the easiest points I can. Let's just bring this down, right? I'm going to check here at x is equal to 0. In between 1.66 and 3, I'm going to check at x is equal to 2. And over here, I'm going to check at x is equal to 4, right? So at x is equal to 0, what is y prime? Y prime is equal to 3 times 0 squared minus 14 times 0, so that's 0 and 0, plus 15. So y prime is equal to 15. So here, we know it's positive, right? That's all I care about. I don't even care the exact value. Once I know it's positive, y prime is positive, I know that y is increasing here because y prime is positive, right? Y prime is greater than 0 means y prime positive. Okay, so that's one region. I need to check all 3 of them. So at x is equal to 2, y prime is equal to what? Now I'm going to plug this in. 3 times 2 squared is 4, minus 14 times 2 is 28, plus 15, right? So that's 12. 12 plus 15, I'm adding those because they're positive, is going to be 27, minus 28 is negative 1. So I know at x is 2, we have a negative value, right? I'm going to put negative here, and I know that y prime now is negative, meaning it's less than 0, meaning it's decreasing. So this is not a region I want to include in my answer. And finally, at x is equal to 4 is my last trial point. Y prime is equal to, well, let's plug it in. 3 times 4 squared is 16, minus 14 times 4. 4, that's 56, plus 15, right? 16 times 3, that's 8, that's 48, minus 56, plus 15, right? 48 plus 15 is 63, minus 56. So I can already tell that that's going to be positive, right? I don't even need to finish it if I know it's positive. I could write here it's positive, and that's all that matters. But let's go ahead and finish that. That's going to be 7, right? So now I know y is increasing over here, right? And how do I write that? Well, I know at x is equal to 1.666, it's equal to 0. So it's not increasing there, it's equal to 0. And at 3, it's equal to 0. And at 2, it's decreasing. So let me go ahead and shade in graphically where it is increasing. Negative infinity all the way over here, and it's going to stop at 1.66. It's going to start again at 3 and go all the way to the right towards infinity. Okay. So to answer the question algebraically, right, I'm going to be able to say definitely that from negative infinity, stopping at 1.66, it's increasing. Union, right, or the region starting at 3 but not including 3, because that's where it's 0, not positive or negative, and we're only looking where it's positive, 3 to infinity. Okay, so I'm going to box this answer, and finally I want to check it because it says check your answer with a graph, right? Check your answer with a graph. So let's go ahead and graph this in our graphing calculator. So turn it on, and y equals, I'm going to clear anything I have there. I'm going to put x cubed minus 7 times x squared plus 15x minus 2. Okay, let's go ahead and graph this. I need to change my window. I'm just going to zoom standard. So let me do that. Let's go ahead and F2, zoom standard is number 6. And yes, I can see that the graph is it's a cubic function in nature, so it goes from negative infinity to increasing until this point right here, right? Which I hope is 1.666, right? And then it decreases for a while, and then it increases again, starting at where I hope is 3. So I can test those points using the maximum feature, right? I could get this point looking at the maximum of this region right here. My calculator tells me at 1.6667 exactly that's where it stops, like that point. So from negative infinity to 1.667. So this region is correct. Now let's check this one. To do that one, I'm going to use the math feature and go to minimum and get the minimum right here to see where it stops decreasing. And we're thinking it's 3, it should be, and x is 3, so perfect. So we checked our answer with our graphing calculator and completed this algebraically, which is analytically. So that ends CPM Calculus Chapter 4, number 102.